2017, Paper 2, Question 1, the line. So here in Question 3, we're given a triangle ABC, and we're told the coordinates A, and we're given the coordinates of C. And we're also given the coordinates G, which we're told is the centroid of the triangle. And we're told then that AG intersects BC at the point P. So in other words, if I was to continue that line from A all the way down till it reaches the line BC, we're going to get a new point, which is the point P. And we're told that the ratio of AG is to GP is the ratio of 2 is to 1. So let's think about what the centroid is first of all. So centroid is basically the point of intersection of the medians. And the median is the line joining the midpoint to the vertex of the opposite side. So that basically means here that we're joining P, which is our midpoint, to A, the vertex of the opposite side. So in other words, this line here is a median. So if we knew what B was, we could basically just get the midpoint of BC and that would give us the point P, but we don't know what B is. The next thing to note is that a centroid will always divide the median in the ratio of 2 is to 1. So that's why we're given that piece of information there, that AG is in the ratio to GP, and that ratio is 2 is to 1, and that's because G is the centroid. So the fact that we know the ratio, well, that's going to allow us then to work out what the coordinates are of P are. So let's just take that line A to P, and we're going to redraw that. So we have A, and that's 0, 6. And then we have G, which is 2/3 and 4/3. And then we have P, which we don't know, so I'm just going to call it XY. So we need to find those coordinates X and Y. Now what we do know is that the ratio of A to G and G to P is 2 is to 1. So in other words, what we're going to do is we're going to call these points X1, Y1, X2, Y2, and then our ratio is A is to B. So in other words, G is basically our internal divisor. And if we go to page 18 in our maths tables, we can see our internal divisor equation, which is B times X1 plus A times X2 over B plus A, and B times Y1 plus A times Y2 over B plus A, and that will equal the external divisor, which we're trying to find, which we know is going to be G. So not to be confused with X2, Y2 that we've marked in there, okay? So if we sub in our values, our internal divisor is G. So that's 2/3 and 4/3 is equal to B, which is 1 times X1, 0, plus A, which is 2 times X2, we don't know, or just X, over B plus A, so B plus A, and then we have 1 times 6 plus 2 times Y over 1 plus 2. So if we simplify that, that gives us 2/3, 4/3 is equal to 2x over 3 and 6 plus 2y over 3. So that means that 2/3 has to equal the x coordinate, 2x over 3, and 4/3 has to equal 6 plus 2y over 3. So what we're going to do is we're going to equate our x and y coordinates. So what we have then is 2 over 3 is equal to 2x over 3. So therefore I can see that 2 cancels on both sides and 3 cancels on both sides, which basically leaves me with x must equal 1. And then we have 4 over 3 must equal 6 plus 2y over 3. And again, 3 cancels on both sides, leaving us with 4 is equal to 6 plus 2y. So we have minus 2 is equal to 2y, and therefore y must equal minus 1. So that tells me that my coordinates then of P are equal to 1 and minus 1. So there was 10 marks going for that question, and it was broken down into 0, 4, 5, and 10. Now you could, of course, have taken, if we go back to that diagram, you could have taken P as being the external divisor and use your external divisor formula. But of course, your external divisor formula is not in your maths tables. So you can always just take these equations and work with them as we have. So G is the internal divisor because we were given that ratio for internal divisor. So for B, we want to find the coordinates of B. And we established in part A that P is our midpoint of the side BC. So we know that P is equal to the midpoint of the line segment BC, which means then that's really easy to find out what B is because we just have to use our midpoint formula. So our midpoint formula again is page 18 of our maths tables, and we know that it's basically the middle point, so the halfway point or the average of the x's and the y's. So it's x1 plus x1 plus x2 over 2, and y1 plus y2 over 2. So we just need to basically sub in our values. So P is our midpoint, so that means 1 minus 1 must equal, and our x1, y1 is going to be x plus 4 over 2, and then y plus 2 over 2. So that's 1. Same as in the last part, we're going to equate our x and our y coordinates. And then simplify. So we have 1 is equal to x plus 4 over 2. So multiplying both sides across by 2 and then getting x on its own gives me minus 2. And then for y, we have minus 1 is equal to y plus 2 over 2. So multiplying both sides across by minus 2 to get rid of our fraction, we end up with y is equal to minus 4. So that means that our coordinate B is equal to minus 2, minus 4. And again, of course, if you plot this perfectly on your graph, you can see your value there is minus 2, minus 4. So the marks going for that then were 5C, which is 0, 2, 4, and 5. And then the last part, C. So C wants us to prove that C, the point C of the triangle ABC, is the orthocenter of the triangle. So we have to remind ourselves, what is the orthocenter? So the orthocenter is basically the point of intersection of our altitudes. So what's our altitude? So the altitude is basically the perpendicular line from the vertex to the opposite side of the triangle. So what that basically means is that A to C must be the vertex to the opposite side, which means that that must therefore be perpendicular. So in other words, AC must be perpendicular to BC if C is the orthocenter. So in other words, if the orthocenter is one of the vertices, then the triangle ABC has to be a right angle triangle at the point C. So we're basically going to show that AC is perpendicular to BC. So to do that, we're going to get the slopes. So if we take A, which is 0, 6, and C, which is 4, 2, then if I call one point x1, y1 and x2, y2, I can get my slope formula, which again is page 18 in our maths tables. And by subbing in, we can end up with our first slope is 2 minus 6 over 4 minus 0. So that's minus 4 over 4, which is minus 1. And if I do the same then for the second point, BC, well, b we've worked out is -2, -4. And of course, if you've got the value for b wrong, you'll still get your full marks for doing this part out right. So we have BC, and again, if I call them x1, y1 and x2, y2, then M2 is going to be y2 minus -4 over x2 minus -2. So that gives us 2 plus 4, which is 6, over 4 plus 2, which is 6. And therefore the second slope is +1. So of course, if these two sides are perpendicular to each other, then we should check by multiplying M1 multiplied by M2. And that should give us -1. So M1 is -1 times 1. And therefore that tells me that M1 times M2 is -1. And therefore they must be perpendicular. So AC is perpendicular to BC. And therefore that means that C is equal to the orthocenter. So there was 10 marks going for that. And it was 0, 4, 5, and 10. Now you could of course work out the orthocenter by getting the point of intersection of the two lines, and you would find that that orthocenter point would be 4, 2 as well.